brittle bits breaking bizarrely, color changing chaotically, and autonomous AI adapted to artisans. All this and more, and a little bit of IT. PrintFix Friday, episode 182. Let's get into it. Starting off with inconsistent and brittle PETG. We have black PETG here, which is the Creality CR PETG, and the orange is Bambu PLA Basic. Parts are done with identical settings on the A1 Mini. I just hope that it's, slightly different temperatures. And the sockets are printed with the Bambu PETG Basic profile. Of the 5 printed, 3 have snapped, 2 have stayed fully intact, and they're trying to understand why this actually occurs. So what we're looking at is a Lego ball and socket joint from the Technic set, at least from my relatively inexperienced Lego stuff, so Lego nerds, let me know in those comments. But we've got PETG. Being PETG, it tends to fracture before it fails, and that is why Lego is made out of ABS, because ABS tends to stretch and yield a little bit elastically and then inelastically before it completely fails. The way to deal with this, at least on the PETG side, is print hotter. With PETG, the hotter you turn it up to a certain amount, the stronger the part will be. You can also look at annealing your parts in post-production to get them to last longer and be a little bit stronger. However, you need to be careful with that, because if you're not properly dealing with those stresses, the parts can warp during that annealing process. So be careful there. That one is a bit of a trap for the young gamers who haven't really gone down the path of annealing just yet. I would say try higher temperatures with the PETG and see if it works. Mind you, not all PETGs are made equal, and that goes exactly for how they're made. Yes, PETG is an actual chemical, which looks like this and is pronounced like this.
Polyethylene terephthalate glycol.
Not all PETG is actually real pure PETG, and different PETGs can have different makeups of how that glycol gets added. Some companies will add other chemicals to that PETG, often it is talc, as a means to get it to print faster. A lot of your high-speed PETGs have additives in them that make them print faster, often in exchange for layer strength. And in this particular case, while it didn't break along the layer line, it still fractured at a weak point itself. So exactly how should you go about fixing this, right? If you want to keep the ball and socket from getting too loose, obviously you can't expand or contract the parts at all, because over time, they will just become loose. By the way, if you want to fix that, coat either the ball or the socket with clear nail polish. That generally keeps the parts from wearing too much. That should help out. You can do both sides, but then you gotta really account for that extra thickness that you're dealing with. You can go to those higher temperatures, or you can go to an ABS material. Personally, I like ASA. It's the weird uncle of ABS that is a little bit more UV stable and tends to last longer, but hey, Lego figured out that ABS works just fine, so why change a good thing? We can also see that it broke at a bit of a thin point. If you don't need the pinhole that goes through it, you can look at just filling that in. That will make the part stronger. This is absolutely the difference between designing for 3D printing and designing for injection molding. This part was designed for injection molding in mind, not 3D printing in mind, so the failures can occur where that part gets weak and where the stress can rise. Higher temps, different material, life should be good. And as to why certain ones fail and others don't, it can be the luck of the draw. It can be that the PLA parts are a little bit off and they're a little bit different when it comes to their actual diameters. And if you see that seam that we can easily see in the part right there, that seam is a smaller diameter at that point. So depending on how you clicked it in, that might have presented a little bit of an easier scenario before the part potentially yielded and failed. Hope it helps. Speaking of help, my name is Grant, this is 3D Musketeers, and while we don't possess every type of help that you might need, and terribly sorry if you are an American. We can help out your 3D printers, get them back to printing with purpose. And if you do need help with your 3D printers, we can help you out. You can reach out to us on those social medias, tag us in some posts, or my preferred method, utilizing YouTube, making a video of what's going on, tagging us in it, then we'll include it in an upcoming episode here on PrintFix Friday. If you do like seeing print failures and how to fix them, make sure to leave a like and get subscribed, and of course, comment if I got anything wrong and how you might do things differently, and any extra advice that you could provide as well. And hey, if you do appreciate this kind of work, Patreon, PayPal, YouTube channel members, all those ways in the description. We'll talk about it toward the end of the video. Moving on, color shift on Tricolor Filament. What is causing this color shift? Is it print settings? Is it the filament? They thought it was the layers, and then it started a different location, then the seam made them think otherwise. It is an A1 Mini, it is Bambu Studio, and the filament is the Lovun Tricolor Silk. It's tricolored silk. It's a really, really simple answer. The answer is your filament is turning. So not all filament is perfectly round. When you look at buying filament, it is often measured in terms of diameter, but ovality matters a lot too. And when you're dealing with tricolors, or especially tricolor silks, ovality matters. If your ovality changes, the filament itself can actually twist a little bit in that extruder, causing the shift that you see. This can be caused by a slight defect in the extrusion of one of those colors during the extrusion process. Traditionally, it's not a huge issue, and most printers should work through it, but we have seen it become an issue, especially on larger prints with tricolor filament. There's not an easy way to stop this problem. There are some ways to keep the filament itself from rolling around, but ultimately you are trying to force physics in your own particular way. If you can do that and you can keep everything from basically spinning in the extruder, good on you. Quite frankly, I really like that gradient that it created. Like, that's like that perfect color wheel all the way around the printer itself. And as the top comment states, you also want to check to make sure that the direction that it was printed in is consistent as well. If the machine is printing layers in different directions, whether that is clockwise or counterclockwise, that can have an impact on how the filament is deposited. Because think about it, if you go printing in one direction, and instead of continuing to go around in that direction, you go backwards for a few layers, yeah, that can actually be a big deal. There are also certain extruders that can assist in this twisting, that help guide the filament down much straighter, but realistically, if you're running a Bambu, you can't run that equipment, so it doesn't matter anyways. Unfortunately, this is one of those fun problems of printing multicolored filament, where the filament itself is the multicolor, and it is done on a tri-extrusion or dual extrusion level system. And outside of trying a different brand and hoping it doesn't have those problems, there's very little that you can do other than making sure that the print direction is consistent throughout the entire print. If you have other bits of advice to provide to this user, please let us know in those comments. We don't print a lot with dual color or tricolor silks, or silks in general, because we don't find that the giveaway of the layer strength is worth it for the appearance of the parts themselves. And quite frankly, it does appear that this thing is twisting even a little bit. You can see lots of areas where the red and the yellow are shifted. However, that could also just be down to bad extrusion. So if you have any other tips or tricks, let us know in those comments, because this is not a big area for us in terms of experience. We just know what causes the problem, but not necessarily the exact perfect ways of fixing it. If you guys would like us to do some testing with tricolors, let us know. But I think having a ovality meter or some way to test ovality would be pretty important for that kind of thing. Next up, a bit of a lesson as to why I absolutely hate cloud-based 3D printing and just dealing with network security in general. I'm logged into someone else's printer. Please help. From the Creality 3DP subreddit. So it originally had 2 printers, but one is currently powered off and in storage. However, I just noticed that a Sonic pad was still showing as online and actively printing. Then I remember that I had ordered a Sonic pad a while ago, but then had to return it due to a broken connection. It seems like the manufacturer didn't factory reset it, and now someone else is using it while still being logged into my app. Right now, I have full control over this person's printer. I can monitor the print, change the settings, and even stop it. Does anyone else know how I can log out of the Sonic pad, or if anyone recognizes the failed print and can log out of my account? This is why we did our deep dive into the Bambu Lab log files. We wanted to know, since you can't clear the log files, what is in them if you ever do have to send your machine back to Bambu. And what we found there was quite troublesome. Even after a real factory reset, the log file stayed relatively unchanged, and that's a huge issue if you're printing parts that have any amount of NDA or proprietary nature to them. Obviously, with a Sonic pad, which is more of like a clipper control pad for a 3D printer, it poses similar risks. You should never, ever trust that a manufacturer is going to factory reset a device when you send it back. You need to make sure that you are the ones that do it. In the event that you can't factory reset it, you have to decide, is that network security risk worth it to you? And someone that buys a refurbished computer of sorts has to realize that those can come with potential problems. Hopefully the user is able to notice this issue, be able to factory reset their Sonic pad, and hopefully be able to reconnect it with their own account. But as a top comment says, be their AI, monitor prints, and cancel on failures. I worry because this isn't the first time that we've seen this, and thankfully this person's not being malicious. They have no reason to be malicious, but that doesn't mean that someone else brought into this position would not be malicious. What you can clearly notice about this is that the printer can see outside of its own build volume. We can see the stucco color on their walls. So if this camera was pointed in a different direction, you know, maybe they chose a more, let's go with free lifestyle, and they walked around with a little bit less than the appropriately publicly accepted level of clothing, we could be dealing with an odd case of voyeurism. This is a bit of an issue, something that you don't ever want to have happen if you ever need to return products like this. It's why we tell people to be very careful with anything that is cloud connected, whether it is a camera, a printer, a screen. All of this can present potential security vulnerabilities. Now, is this necessarily Creality's fault? I don't know. We don't trust manufacturers to do that level of care when dealing with refurbished products like this. And quite frankly, I'm not even certain it went back to the manufacturer. This is like something that was bought from Amazon. It just gets returned. Amazon says, looks good enough to us, and puts it back into the new products. It would be very convenient if one could log out of printers on a Sonic pad and on the app itself so that this user could just voluntarily log out. But I can certainly see this being a problem, because if you are the user of this Sonic pad, you have no clue, as far as I'm aware, that somebody else is watching you. I always feel like somebody's watching me. And let's be real, if someone's watching me, I want to get paid for it. Like and subscribe, donate on Patreon, and help support the channel. Next up, talking about bed adhesion here, we got ourselves a Voron 2.4, where that honey badger plate from Fabrico did a damn fine job of making sure that those parts did not come up. We have had phenomenal experiences with the honey badger plates here. Personally, we run them on our Bambu, and I tell you, it is one of my favorite build plates. The smooth and the textured both work incredibly well. They stick really well, and I've seen similar issues myself, where the freaking build plate doesn't give up, the magnet does. We've seen companies look at ways of solving this, and in fact, I saw a post from a 3D printer manufacturer where they had a locking system for their bed. They have since deleted it, unfortunately, so I won't mention that manufacturer. However, I do think it's a really cool way to keep your build plates from warping like this, and I would like to see more manufacturers look at implementing a system that does lock in the actual build plate. We shouldn't have to go back to the good old days of putting binder clips on the side of our build plates to keep them from warping up like this. This is likely a ABS, ASA, or a nylon print. Given that it's a Voron, it's a 2.4. These machines are made for this kind of material. But if the chamber temperature isn't hot enough, you will end up with warping. And on parts that are really big and really flat like this, it does appear that this could be Gridfinity. I don't know. Gridfinity experts might need to let me know in those comments. But on big flat pieces like this, ABS, ASA, nylon, polycarbonate, any of the higher temp materials are going to have warping problems unless you are actively heating and controlling the chamber temperature of your 3D printer. A great way to deal with this is to not only actively heat the chamber, but when the print is done, actively cool it down by slowly lowering the temperature rather than just shutting off the actual heaters themselves. You can control the ramp down of temperature inside of that chamber. With higher temp materials, you can crank those temperatures in that chamber and the part will love it. But if you thermally shock it, it will have a tendency to shrink and warp up, as we see. You can look to just heating the ever-loving sin out of it and hoping that those extra stresses inside of the material work themselves out, but often they just don't. In our experience, a design on the build plate similar to what we see on the top of this part with that checker pattern would reduce the amount of warping that we see, because the warping like this occurs when the whole part itself shrinks. But if its contact patch is lower to the build plate itself, right, there's less material contacting the build plate, there's less material to shrink. Therefore, you get less shrinkage on your part as a whole. Now, Yontech, great creator. We actually interviewed him a while back. We'll card to that video. Just a guy that thinks completely out of the box and blows my mind with some of the things that he comes up with. Came up with the idea of printing a layer of PLA before using ABS, because the PLA itself won't warp and will attach really well to the build plate and keep the ABS from warping as well. Then those two pieces just peel apart when you're done. Or they don't. It's no big deal if they don't either. That would be a great option for something like this, and I would love to be able to do more of that here on the channel. And if you want to see that, let me know in those comments down below. We are going to be looking at doing an entire testing series as we are coming up on that 50,000 subscriber mark. We want to look at building a testing rig to really go after learning more about materials. Materials that warp, materials that don't, how printing orientation and even infill perimeters and that can impact part strength, and see what's strongest and why, and how can we maintain parts looking pretty and at the same time, you know, being strong as well. If you do like that kind of thing, make sure to like and subscribe. And a huge thank you goes out to those names who are listed right next to me at the $5 tier. And I remember, if you do want to get your name scrolling right next to me, you can do so by joining for as little as $5 a month. And at the $10 tier and higher, of course, you get to come hang out in our private Discord server where quite a few of these people hang out. Like, look at this list. We got a lot of awesome members hanging out here. And hey, if you made it this far, let us know about this new end card style we're trying out. I like it. I think it's kind of cool, but I'd love to know your thoughts. But if you do enjoy this series and you want to see the rest of it, right below me will be the entire PrintFixFriday series. You will be able to see over 180 videos talking about print failures and how to fix them. We have the big 200 coming up. I think we're going to do something special for it. And right next to that will be our tour of Construct 3D, a video that has opened many eyes to seeing how quality products can actually be made for what is a very reasonable price. I think you guys will enjoy it. We had a lot of fun filming that video too, hanging out with the folks over at Construct 3D. That is all we have for you all today. Stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one.